let's keep going with more interesting things that we can do with sets. Okay, so let's talk about union. So what is a union? The union of two sets is a set that contains all of the elements that are in A or in B. So let me give you an example to make a little bit more sense of this. So let's say we have two courses and we want to create a set of all of the students that are across the two courses. But the reason we want it to be a set is we don't care if we don't want duplicates, so we only want each student once, but we want to make sure we get all the students across the two courses. So here's an example of how I could do this. So let's say course A students are Sarah, Jordan, and Tyler, and course B students, Jordan and Tyler are also in course B, but Nat and Kendrick are also in course B. So all students is the new set I'm creating by using a union. So I do course A students dot union, pass in course B students, and this will give me the union, or a set that contains all of the elements in both A and B. So here's what our output would look like. We would get Sarah, Jordan, Nat, Tyler, Kendrick. So this matches up to what we would expect from a union. It has all of the students across the two sets, but because it is a set, there are no duplicates. So that's kind of how we could use a union. And then there's two more things that kind of go along these lines that are pretty useful with sets. We can take the intersection of two sets A and B. And what is an intersection? So it's where the two sets literally intersect. So it is a set of all of the elements that are in both A and B, assuming that our sets are A and B. So we have everything in set A and we have everything in set B, but I care about what's in both of them. So let's talk about an example as to where this might be useful. So let's say we want to create a set of students now, but we want to check if they're in both courses. We don't just want all the students like we did last time, but now we need to know, are they in course A and also course B? So here's what this might look like. We have the same two sets, course A students and course B students. I create a new set called all students, which is poorly named because this isn't all students anymore, but we'll leave that for now. And I do course A students dot intersection course B students. When I print this intersection, what would I expect to get? Jordan and Tyler in the new set. This makes sense because we are looking for the intersection, or what is in both sets. And Jordan and Tyler are in both of the sets. Cool. Okay, and let's talk about the difference lastly. So a set containing the difference between two sets A and B has elements that are in A but not in B. And I think this will make more sense as we go through an example of what I mean by this. So let's say that I want to know which students are in course A but not course B. How would I do this? So same scenario again. We have two sets of students, course A students and course B students. So all the students in course A and all the students in course B. So again, I poorly named this all students with some poor copying and pasting, but ignore the name all students. That doesn't really make sense in this case. So let's say we call course A students dot difference course B students. So this will tell me which students are in course A, but take away the difference, so any students that are in not course B, and give me that list. And so what would we expect to see in this case? So remember, we're looking for everything in course A, or all the students in course A that are not in course B. Okay, so we get back Sarah, and this makes sense because Jordan and Tyler are the only two other things in course A, but they're also in course B, so they're not part of the difference. So that's a scenario in which maybe difference would be useful. So let's try coding these out a bit with a similar example. Okay, so let's say I had the same example we've been using this whole time. In the list, we'll use single quotes actually. Sarah, Tyler, Jordan. Okay, we have this in a list. And let's create another list actually. So we'll call this students 1, and then we'll call this students 2. Let's say Tyler and Jordan are also in this list, and then let's just throw in one more person into this list. Okay, so remember the first thing we talked about was the union. And remember, union is the things that are in both of the sets, but everything in both sets. So let's take a look at what we get when we just call students1 dot union, and we pass in students 2. So what would we expect to see here? We would expect to see Sarah, Jordan, Kendrick, and Tyler all in a list. So it's everything in the two lists combined, but of course there are no duplicates in the set, so we just get back one of each. Alright, now let's take a look at the second thing we talked about, which is the intersection. We know that intersection is the things that are in both lists, and they strictly have to be in both lists to be considered part of the intersection. So let's try this out. What would we expect to see here? We would expect to see Tyler and Jordan because those are the two students that are in both lists. In both sets, not lists. I keep doing that. Okay, so that makes sense. We're able to gather information on which students are in both sets. Now let's say I wanted to know what students are in my first set, but they're not in my second set. So we'll use difference here. Okay, so similar to the example from the slides, Sarah is in students 1, but not in students 2. But what if I wanted to switch these? Let's say I wanted to know the difference between students 2 and students 1. What would I expect to see here? Kendrick, which makes sense because Kendrick is in students 2, but not students 1, and Tyler and Jordan are the only other options, but they are in both sets. So those are some functions which could prove to be useful whenever you're dealing with sets.